All right, hello and welcome to our first day looking at volume of various three-dimensional figures. We're going to go through the notes, so make sure you're jotting this down as we go as an example, and then in your practice for tonight you won't have to do the problems that we did together. All right, for number one, we're going to be looking at the volume of a rectangular prism. The first thing I want you to know, the great thing about volume is that the formula for all volumes of all prisms and cylinders is exactly the same. Our volume is going to always equal the area of the base times the height of the prism. So just remember that that capital letter B is standing for the area of the base. So here in this case, when we're looking at our three-dimensional figure, I'm going to outline this base in red. So this is what we're going to find our area of. So our volume is going to equal 9 times 21, because that's the area of our base. And then we're going to multiply that by the height of our prism, which is 7. So when we do 9 times 21, we get 189 times 7. So our volume ends up being 1,323 feet cubed. Because whenever we're looking at volume, we're really looking at how many little cubes we would fill our figure with, if you think about it that way. Now let's look at a second figure. So the second figure, which is number 5 on your practice tonight, is a triangular prism. So we're going to do that same type of idea. So remember, it's going to be the area of our base times our height. So I'm going to go ahead and I'm going to outline our base, right, which is a triangle. So the first thing we're going to do is find the area of our triangle. So remember, area of a triangle is 1/2 the base of the triangle. So in this case, the base is going to be that 12 times the height of our triangle. So as we're looking here, the height of the triangle is this line right here, not the height of the prism, but the height of the triangle, which is 8.6 millimeters. That's going to give us the area of our base, and we're going to multiply it by the height of the prism. So basically the distance between the two bases. So here it's going to be 9 millimeters. So 1/2 of 6 is, or sorry, 1/2 of 12 is 6. And then I'm going to take 6 times the 8.6 millimeters. We're going to get 51.6. And then multiply that by 9. So our volume is going to be 464 4/10 millimeters cubed. At this point, I'm going to ask you to pause the video and actually try this problem on your own first and see how you do. So as you are going through, hopefully you notice that it's a trapezoid. So once again, we're going to find the area of our base first. So area of a trapezoid means we're going to take 1/2 times the height of the trapezoid. So in this case, the height of our trapezoid is going to be 22 because it's perpendicular to those two bases, times our two bases added together. So here, those two bases are going to be 34 and 19. And then we're going to multiply that by the height of our prism. Now in this one, it looks like 22 is the height of the prism, but you have to think about the fact that this trapezoid would be laid down flat. So the height of the prism, like I said, is the distance between the two trapezoids, so it's going to be 8 meters. 1/2 of 22 is 11. So now I have 11, and then 34 plus 19 gives us 53. So if I take 11 times 53, I get 583, and I'm going to multiply that by 8 because that's the height of our prism. in the end, we end up with 4,664 meters cubed. And the last figure we're going to look at is a cylinder. Same type of idea. We're still going to find the area of the base first. So remember, with circles, our area of our base is going to be pi times our radius, which is 10 squared, and then it's going to be multiplied by the height of our cylinder, which is 4. 10 squared is 100. We're going to use 3.14 for pi still. So this becomes 314 times 4. So our volume ends up being 1,256 millimeters cubed. Hopefully you got that all down in your notes. If you have questions, you can check with me later or send me a message. Otherwise, you can go ahead and get started on your practice.